Hello, okay, my apology. I think there's some technical error. Allow me to share. I can't share screen. Hang on a moment. At least it's okay. You give me the codes, right? So I can share screen again. Thank you. All right. All right. We Love Science Advanced Series is basically for Singapore Primary 6, Sec 1, and Sec 2 chapters for science. All right. It's interlinked with the We Love Science series in the past. So whatever I'll be teaching for the next 24 weeks, right, will be somewhat linked to We Love Science basic level. So I know that's We Love Science 1. So without further ado, let us start the today's lesson in proper. So welcome all to week 1 We Love Science Advanced Level Workshop Series, Diversity, Physical Property. This is the overview of what we're going to cover in this series of advanced course. We're going to cover diversity. We're going to look into all the non-living things and living things. First, we look at the physical property of matter. In the previous workshop, I've shared that matters have 3 types: solid, liquid, gas. Then we move on to chemical property like element, compound, mixture. We'll be looking into the periodic table that will be shown in the next 2 lessons. And so on and so forth. We have models, system, and interaction. All these chapters are interlinked with the basic level. So if you want to have a basic foundation understanding, you have to go to look into all the video series week 1 to week 24 videos that's on YouTube, the e-knowledge source. All right. So without further ado, let us start. So today we're going to talk about 3 different things. Classifying non-living things. What are some of the physical properties? What are some of the physical properties of material? Given that looking at the words, right, I'm sure you guys sound, for those who have joined us since the beginning, you sound familiar. It's basically similar to the material chapters and the matter lesson of the We Love Science workshop. Right? So let's recap again what actually happened last time. What is a matter? A matter refers to anything that has mass and volume. Mass is amount of matter something has. Volume is the amount of space something occupies. Be it solid, liquid, gas, there are molecules around us. So all these takes up space, takes up mass, and that's why it's called matters. Back in lesson 5 in We Love Science workshop, we only talked about one simple thing, which is material. We classify non-living things as material. We have wood, we have matter, we have ceramic, we have plastic, and so on and so forth. So there are actually 2 ways, right, for you to categorize non-living things. By materials, wood, metal, ceramic, plastic. By matter, solid, liquid, gas. All right. Or also by man-made or natural. So there's different ways of classification, but for this chapter, we are looking into matters and materials. So how do we choose which material to use? Well, if you are in the previous lesson, at lesson 5, remember the 3 pigs. The 3 pigs trying to build a house. One choose the hay, one choose the wood straw, one choose the brick. So back in lesson 5, the pigs basically categorize the materials and choose based on the pig laziness and their areas of what they want to achieve. So grouping material is an easy method to study the properties and to spot any differences or similarity within the group. Back in lesson 5, we have identified a series of fields properties like transparent, glass, soft like fabrics, clothing, flexible like rubber, waterproof like plastic, opaque like wood you can't see through, hard, diamond, inflexible like some metals, not waterproof like cotton, So all these we have classified them using transparent, soft, flexible, waterproof, opaque, hard, inflexible, and not waterproof. But all of these, right, is not enough to identify which material to use for building or making something. For example, plastic is waterproof, but it melts when it encounters heat. I'm sure you don't want your house to be under the hot sun, suddenly it melt, right? So therefore, this chapter today, we're going to look into what are some of the physical properties that we should actually check before we choose which material to use. So these are the 6 different types of properties. We have strength, we have hardness, we have flexibility, we have electrical conductivity to see whether can electrical pass through the material. I'm sure you do. I'm sure when you want to plug in your computer to play game, right? You don't want your wire to be plastic, right? You can't on your computer. The computer wire should be in copper. All right. We look at heat also to see whether can this transfer heat. And last but not least, the boiling and melting point. Like I mentioned in the previous slide, you don't want your house to melt suddenly in the hot sun. So all these properties are we are going to look at them one by one. Strength. Strength refers to the ability of a materials to support a heavy load without breaking or tearing. So at your house, you can find whichever material you want to find, like or wood or rubber or plastic. You try to let the plastic hold something heavy. If the material were to break, this means to say that it is not so strong. But if a metal like in a material like metal or steel is strong. It can hold wood. It can even use to make seesaw or string or swing. All right. So steel is a strong material which can be used to make metal chain. I'm sure you don't want to use paper to make a chain, right? Imagine your chain suddenly just break or water just destroy it, or your goods fall down. So this strength is one of the properties that you must consider when choosing what material to actually use. Next property, we look at hardness. Hardness refers to the ability of a material to scratch another material. A material can scratch something softer than itself, but not one that is harder than itself. We look at these hardest scales from 1 to 10, 1 being the softest, 10 being the hardest. You cannot ask quartz number 7 to scratch a diamond. The quartz will break because it's not as hard as a diamond. So our copper coin is usually between 3 to 4. So we can use a copper coin to basically scratch anything below 3, 2, or 1. All right, next. Yes, I saw someone hand raising. Any questions? Oh, no, okay. All right, so why do we need to identify whether is it hard or soft? Because while we're making some stuff, we want to make it into the shape that we want. It's just like, for example, your father wants to buy a ring for your mom. And if he were to make himself, he must choose something that is hard, in order to craft something out. Cannot be providing some soft material. In the end, everything goes break. Then the effort is gone. So remember very clearly, hardness is allow you to see how do you make the material into the shape that you want. All right, next. Flexibility refers to the ability of a material to bend without breaking and return to the original shape. One example is rubber. No matter how you stretch, it will go back to the original shape. So rubber is flexible materials. Wood, however, on the other hand, is the inflexible material. Next, electrical conductivities. This property basically measure how easy electricity will to pass through it. I mentioned earlier just now, if you want to make a laptop charger, you cannot use rubber or plastic to make one because plastic and rubber are poor conductor of electricity. You have to use copper, which is a good conductor of electricity to make the wires to charge your laptop. All right. Next. Thermal conductivity is basically how heat passes through the material. I'm sure that when you are making a kettle, you want the water inside to boil, right? You don't want the water inside to stay as it is, right? So therefore, this property will allow you to choose which type of material suitable to make a kettle. Next. Now we come to the last point. We have freezing, melting, boiling point water. Let us use water as an example for this property. Melting point refers to the temperature at which the material changes state from solid to liquid. Boiling point, on the other hand, refers to the temperature at which a material changes state from liquid to gas. So what's melting and boiling point going to do with me trying to build something? As mentioned earlier, if you want to build a house that is sustainable, can sustain the heat, you must check whether this material, how high is the melting point, how high is the boiling point, etc. But we look at melting point the most. So whenever you build a house, you cannot use ice to build a house in Vietnam or Singapore, right? The ice will melt and your house will go disappear. So we have to look into which are the materials that can withstand the hot sun, like wood, brick, kind of material, etc. All right, next. So after going through the 6 properties that we're going to go through this chapter, we must consider property to choose the best material as mentioned just now. So let's recap what we have learned back in lesson 5 in William Science. We talk about flexible, like rubber, leather, plastic, fabric, or leaves. We talk about hard, like diamond, plastic, brick. We talk about soft, like cotton, leather, rubber. We talk about transparent, like glass, ice, diamond. So by incorporating what we have learned in lesson 5 and what we learned today, we combine together. This gives you a generic overview on what you should choose, what material you should choose, etc. For example, number 1, plastic. We know that plastic actually is used to make plastic bag, plastic food container, plastic electrical socket. Why do we use plastic to make plastic bag? Because it's flexible, it can stretch, it can hold things that's beyond what it should hold, but not to the extent. Yeah, low density, it is strong, so plastic container is strong. And why do we put plastic as the material for electrical socket? Well, I'm sure you do want to get electrocuted when you are opening the when you are on the switch, right? So because plastic is a poor conductor of heat, therefore it's chosen to make electrical socket to protect us from all the electrical currents. Next material, we look at glass. We have glass window panel. Why do we use glass as a window panel? Because it is not flexible, it is brittle, as a poor conductor of heat and electricity. Thus, the house can actually let go some heat, etc. Next, we have metal, ceramic, and fiber. All these things you can take a look later. Let's carry on. Now, after talking about materials, physical properties, so on and so forth, let's look at what is density. Different substances may have the same mass, but they don't necessarily fill up the same volume. I can have 1 kg of cotton, I can have 1 kg of steel. They all come in different shape and size. They don't fill up the same volume, or they don't take up the same amount of space. All right. Therefore, we have density. Density is a measurement of how much mass is contained in a given volume. In simple words, it basically means, right, how many things we stuff inside. Just like a soft toy. How many cotton can you stuff in a soft toy? So we use this, use density to measure. So how do we calculate density? All right. To calculate density, we use the following formula. Density is equals to mass divided by volume. A unit of density is always a unit of mass, such as gram divided by a unit of volume, such as cubic centimeter or cm cube. So depending on the unit, SI unit of the mass and volume, some can be gram per cm cube, some can be kg per meter cube, depending on what is the unit of the mass and the unit of the volume. So, as mentioned earlier, one typical unit of density is written as gram per cm cube or gram slash cm cube, which read as gram per cubic centimeters. The word per means for each, which in the math term it means divide by. So basically means that for every 1 cubic centimeter, every 1 cm cube, we have example 20 gram of materials. All right. For liquids, density is often stated in gram per milliliters or gram slash ml, which is the same as gram slash cm cube or gram per cubic centimeters. The only way to change the density is by changing the temperature or pressure. The higher the temperature, the lower the density. So you can see that the higher the temperature, the density gets lower, because as the temperature gets higher, it becomes it becomes a different state of matter. So therefore, the molecule space are getting more and more bigger and bigger, and therefore, as the temperature goes higher, density goes lower. Next, pressure. As the pressure increases, the volume decreases, causing higher density. So same theory here, as the pressure decrease, volume increase, causing lower density. All right. So it's the opposite of temperature. Why do I say so? Let's say, for example, I have this particular wood. I squeeze, I give pressure, I squeeze and make it smaller. So as a higher pressure, I try to exert to this material, right? The number of density, right, getting more and more squash, being squashed and getting more and more higher. So you can basically understand it from this point of angle. All right. So in summary, increased temperature, decreased density. Decreased temperature, increased density. Increased pressure, increased density. And decreased pressure, decreased density. So how do we determine the density? For regular shape, the mass, we will follow exactly the volume by formula. Cube, cylinder, sphere, cone, etc. But for those irregular shapes, those shapes that you cannot understand what is the size what is the shape of the material, we use water to determine the volume. So how do we do this? How do we use water to measure the volume of this irregular shape? We get a cylinder, we add a water to a certain amount, let's say 90 or 100. In this case, let us give 100. So we add water to a cylinder until you reach 100 ml. Then we throw or we put the irregular shape into the cylinder. As you put the irregular shape into the cylinder, the water actually increases. When the water increases, you record down the new water level. You take the second water level and minus off the first water level. Let's say, for example, after you put the irregular shape in the cylinder, your water level is 120 ml. So previously it was 100 ml. So you take 120 minus 100 ml, you get 20 ml. Therefore, the irregular shape have this 20 ml of volume. All right. This is the sample of the density table. We know that water have a density of 1 gram per cubic centimeters. So anything that is less than 1 will float on water. So wood has a density of 0.85, therefore it can actually float on water. That's why in the past, people use it to make boat. Ice has a density of 0.93, therefore it floats on water also. Then all the density that is more than 1 will sink to the bottom of the water. All right. So students, just make sure you know this concept. As long as the density that you calculated is less than 1, when you say whatever material is, they are able to float on water. For the density that is more than 1, I'm sorry, this material that you have will sink underwater. So this is a simple concept that you must remember. All right. So why water? Water is the standard used to compare the density of object because it is 1 gram per cubic centimeters. So as mentioned earlier, the density of water when the most dense is 1 gram per ml. For example, look at this bottle here. I have oil and vinegar. You can see that after I shake the bottle, I let it rest sometime, the oil will go on top of the vinegar. Why? Because oil has a density lower than vinegar. All right. So you are right if you say that the oil is less dense than the rest of the liquid dressing. The density of the substance is the same for all samples of that substance. All right. Let's say you buy a packet of oil. You buy a packet of oil, a bottle of oil. No matter how many bottles or cylinders you want to test, all will give the same result because they are from the same sample. For example, all pure gold have a density of 19.3. No matter how you cut or how you were to make it, it is still 19.3. All right. Therefore, density is another example of a chemical property which you will learn in future lesson. All right. One example. Let me give you an example. All right. A small block of wood has a volume of 25 cubic centimeters, means 25 cm cube, and has a mass of 20 grams. What is the density of the wood? Will it float in water? So students, when you see this in the examinations, remember to find density, the formula is mass over volume or mass divided by volume. Therefore, D equal to mass over volume. Mass is 20 grams. Volume is 25 cm cube. Therefore, 20 grams divided by 25 cm cube is 0.8 grams. So will it float on water? Yes, because the density is less than 1.0, which is the density of water. All right. The next question. A rectangular block of copper metal weight 1.896 kg. The dimension of the block are 8.4 cm, 5.5 cm, and 4.6 cm. From this data, what is the density of copper? Looking at the question, right? They did not give you the volume. You have to find the volume yourself. Yes, Mian.
So first, so I answer how to solve this.
Oh, sure. Sure. So first of all, you must find the volume first.
So first, you need to know the mass, the volume of the copper,
Yeah.
the copper block. So you take 8.4 times 5.5 times 4.6, and then divided by the kilogram, divided by the weight, right?
So yes, so 8.4 cm times 5.5 cm times 4.6 give you a volume of 212.52 cm cube. So now we know that after we do the length times breadth times height, we got 212.52. Then now we basically use the formula, which is mass over volume, which is 1896 grams over 212.52 cm cube. and you get a density of 8.92 gram per cm cube, which means to say, right, students, this will definitely sink under water. All right. So that's all for today. Presentation is a short one. I'm going to share this PowerPoint to the Zalo chat later on. So I think Alice has prepared a quiz, right? So maybe can Alice take over the quiz portion. Thank you.
I think Menon will run it for me.
No, I'm really sorry because I'm in my hometown right now. I only got my iPad, and my iPad is like 7 years old now. So
No worries, no worries. So maybe Alice can help to open up. I will share the PowerPoints to the Zalo group chat later after lesson. But bear in mind that this course is for 10 years old to 16 years old. You are welcome to join the course if you are below 10, because it's good for you to get exposure. But should you have any questions, you can look into the YouTube channel with e-knowledge sources, whereby we have recorded the past We Love Science series workshop. From there, you can get a better understanding before you join this course. So now Alice is doing now, right?
Okay.
So is everything okay, Alice?
Oh yeah.
Right.
Just wait me 1 more minute.
So it's good to see everyone, those people that I know of. Welcome back. All right.
What is this?
Right, let's start the game now.
Alice, this quiz only maximum 60 players. So you just started. Yeah.
I thought there were more.
Oh, here. Wait. Let's see if I can join one more. 8, 1, 5, 1, 8. If I know correctly, you can only. Game is full 60 minutes. 62. Okay, start.
Sorry.
Oh, it's
But
101.
like super lag.
All right, let's start.
Oh.
No worries. I think the other side, I think all the people can play, right?
Maybe Alice, you share the screen, and then let's know who could not join the game can play with you.
Oh.
Or Andrew share the. Anyone on Nhân Nghĩa, are you on the game?
No.
You cannot. Who is in the game? You can share the screen and let everyone look.
Oh no, the game is locked out because she's turn off the host one.
Or you close it, Alice?
Yeah, because it didn't work. And it also sent me a message that limit 16.
It's okay. On the game will be 60. So the first 60 we play and the rest we play on the screen.
Oh.
All right, so the first 60 is now playing now, am I right?
Yeah.
All right, so now let's proceed to the next 60.
Okay. Yeah.
Teacher,
So you close the game? Open the game.
Yeah. I think the internet is so lag.
I saw a polar bear.
It's like lagging so much for me.
can you start it? My internet connection is not very good. I think you have
Okay. I will try joining from from my brother's iPad. Wait a bit. Wait. Wait.
Can you start it? Or should I?
Maybe you should start. I'm having a bit of difficulty. Okay. Maybe you can try start.
I'm trying, but my computer isn't
You want me to open?
Okay. Did you see my other nickname? Let me
I'm
yeah.
gonna
Do you see my other nick like Minh Anh 2? I was trying to do like that.
No worries. Take your time.
Wait. I'm trying because I like need to send the passcode and like.
I'm gonna share the screen so I can see the
wait, I'm gonna on my iPad. I'm gonna share my screen.
Wait. Okay. Right. So can screen. Share the screen. Well, Wait, let me log in from Looklet first. Oh my God. Sorry, today is like,
No worries, no
But-
worries.
but I think there's something like wrong about the internet these days.
All right, Alice, can you send me the username and password? I see whether can I log in through my site.
Oh, okay.
Oh,
Yeah, you send me right now, check. Yep. So
Let
I
me- You on the private.
send me in downloads, okay? Send me in Zoom, okay? Give me 5 minutes. Let me see whether can I log in.
well, wait, I'm already logged in.
Okay.
So I'm gonna send you privacy on Zoom.
All right. So it's booked, right?
Yeah, look at.
Okay, hang on. Let me try to log in to see whether I can log in. Right, at least you send me the password and username. Let me try to.
Do you need help? I can do it.
Oh, you can do it, is it? All right. This is my first time opening up this thing. Hang on,
Okay. I think I got it. I got it.
You got it?
Yes, I pretty much got it. Wait, no.
No worries. At least send me the username and password.
My set today it's okay. Here let me share my screen a bit on my other account. Screen start girls. Oh my god.
Right.
Here. Okay, so you see the screen right now?
Yeah.
Okay, so let's start the game
Okay.
then.
Let's go Detective Dinos.
All right, students. Now back for those 60 and above.
Wait, okay, let's, sorry for the black screen. I have to like chat. Okay. I will send it to Alice and then okay. Internet. Okay. Okay, just tell me when you need to start. I can't join, so yeah, good luck.
For those who see the link in the chat, let's join in. All right, just now I mentioned very clearly is that density is mass over volume. All right. This question confirm come out later.
Maybe we should wait a bit because we have like over 100 people, so we might get to 60.
Yep, no worries. All right, maybe we can start now, shall we?
I think I can't see any instructions.
Everything work?
I can see instructions. Instructions and look at a host on a host screen.
Okay.
Who is sharing? Is it Alice?
No, it's Mina.
Manan? Okay.
Can I will share? I will share. I think I get it already. Okay, gentlemen, ladies and gentlemen, boys and girls. All right, let's start. I think I'll just choose crypto, shall we?
No, please.
Go
Sorry.
Quest.
Go
Oh, yeah.
Quest. All right, Go Quest. Host game now. All right, boys and girls, I'll give you a timing of only 5 minutes. All right. So 5 minutes. Okay, then I will host now. I'm going to share the link now. The chat now. So everyone, please
Wait,
join the teachers.
You have to copy again.
Okay, okay. All right, copy again. All right. Okay. I mean, copy 3 times. All right, students. Now it's been no issue already. So please join the game and have some fun. All right, all right. Wow, 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 wow. 3, 3, 3. Wow, 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 wow. But yeah, 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 yeah. 8, wow, 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 wow. 10. Oh, yo, 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 yo. Oh, oh, yo, yo. Oh, you go so fast. Slowly. Yeah, 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 yeah. 30 already. Wow, 37. Oh, what 31. This is not a soccer. This is not a soccer game. 38. Anyone else join? Come on. This is now teacher Andrew hosting. So you should now come. Let's play. 42. 42 is a very nice number. 42, 42. 43. Okay. 43. Let's say the 4, 4 are very, very unlucky number. 4, 5. Okay. 4, 6. Yeah, 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 yeah. Yeah. Wow, 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 wow. Yeah, yeah, yeah.
Wait.
Wow, this one.
When you up to 60, you have to start immediately. All right.
Yeah, no problem. All right, 8 more person to hit 60 jackpot. Who will be the winner? I can't see who the winner, but I'll randomly guess a name. In 3 now. All right, boys and girls, we have 7 more. Who is the lucky one for this game?
6 more players.
So welcome to the We Love Science city hosting person. Thank you for being the 60 participants for this game. Come on, come on. 4 more. Anyone? We say da 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 da. Wait, 2 more. Wait, why you leave? Why you leave? Why you leave? 3 more. Okay, starting in 5, 4, 3, 2, 1, start. All right, let's start. Your sound is
Okay, get that one.
okay. All right, let's start. What? 15 minutes? Okay lah. Or at least the cartoon very cute. I got at least learning why something. For information, I like to disturb people, so please ignore my nonsense. If you can take my and get full mark, I applaud you. Wow. Canon just swap go with Hui. Canon is the printer, right? So you are from a printer company. Then we have Min Chow, just swap go with Eric Pro. Eric Pro, always in the lesson. Thank you very much for support.
Can I leave early?
Now Tin is the first. We have mentioned sushi or sushi. I like sushi. Where's the wasabi? What? Come, where's the sushi? Sushi is here. It costs $405. No money to buy. Sushi, you see? Wow. Wow. Jasmine just took 8 gold from Cat. Harry 21 just took 170 from Cora. Why do you call on Harry 21? 21 hair? Oh, and it's aliens. Alright, nice to see you, alien. Your first planet. Mars? Joseph is now first. Yes, Luca. People playing game, you will say, how the hell can I help you?
I don't know why I can't log in.
Okay, I will share the. Oh, I think I already blocked you already. When I start the game, right, it means that it's carry on already. So sorry about that. I've been seeing Canon all the way. There any HP here or Sony here? Maybe Acer or Lenovo? It's not bad. I speaking nonsense, you also can get so much so high goal. Not bad. But Ao Chao is the first, followed by Ong. Hey, why become 0? Ouch. This game is very cool. Tony, you are now 30 points at K. Can you hold the title? Or not worry. You jump triple. Ladies and gentlemen, Mr. Tony now added rating 68.8K. Oh, wait. Now he gone missing. Now Alien is at the top. 91.7. It's now taken over by Lin Run. Oh, now we are Joseph. Yes, Luca. How can I help you?
How can I play?
I don't think you can play after the game is being joined. I'm so sorry about that. Maybe next week I will start this game again. Okay.
Okay.
Sorry about that. So sorry. Meanwhile, enjoy my nonsense. Alex is always the top. What? What, Alex? Yeah, correct. Now it's 5 1. Oh, I got Lucaro. Yes. Long time to see you. Hi, Lucaro.
I tried to join, but I can't join.
No worries. For those who cannot join, no worries. We will play the game again next week before lesson. All right.
Okay.
So I'm sorry for those who can't join. Meanwhile, enjoy the screen and my nonsense. It seems like the students here like to swap goal and took goal with everyone. Everyone can be an entrepreneur. Boss in making. Oh, now it's 4.1 million. I'm sure you guys got a feeling whereby when you hit $1 million, suddenly comes 0. No, really, this is a game, so no hard feelings. The main thing is you should know the concept, right? Okay, how do I end? Oh, okay. I'm going to end the game in 1 minute time. So when the clock strike 0759, I'm going to end the game. So if you want to took any goals or stop any goal, faster stop, have exactly 44 seconds to stop. I want to see who is the lucky one that shot first prize goal in the last second. 26 seconds to go. Boys and girls. 19, 18, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Kaboom! Oh, I do on time. Right, congrats, Joseph. You have, I don't know how to count, 363 199 324. Then we have this V, is it? It's 363 199 324. Same. Then we have Murat 321 292 296. All right. Thank you all for your participation. All right, that's all for today. I will see you next week for another lesson of We Love Science Advanced Level. Thank you very much. Goodbye.
Thank you, Andrew. Hope you enjoy the class. With
Bye.
over 100 students.
Wow, that's wow. Okay.
All right. Bye,
Bye,
everyone.
bye, Bao Chao. Goodbye,
Goodbye,
students.
teacher.
Bye, bye. Take care. Enjoy. Goodbye, Murat. Bye, Bao Chao. Goodbye. Bye, everyone. Take care. Bye, Sophia. Bye, Jack. Bye, Alice Pan. Bye, Alice Le. Okay. You got 2 Alice here. Then we have Henry. All right. Then we have oh, bye, Polar Bear. Nice to see you in Vietnam. I will come to your lesson soon. All right. So take care. Bye bye. All right. Bye, Henry. Bye, Kelly. Bye, Peter. Bye, Sophia. Bye, again. Bye, Katrina. All right. Well, I have some person who download